In the last few videos, we've been trying to get at some concepts about addressing modes, and on the way I asked you to just sort of believe that some of these variables were defined properly. In this video, I'm going to go into a few details about how variables are defined, and I hope that it'll clear up some confusion that came up in the last few question and answer sessions. So today we're going to sort of demystify this section. Now, normally I'd be saying, hey, let's go look at the book to understand what's going on. Unfortunately, this is a case where the book lets us down. Despite when I said this would have all the concepts needed for the class, it turns out not to be the only document of interest for this microcontroller. Instead, there's an entirely separate manual called the HCS08 Family Reference Manual. This is not unusual. Many microcontrollers are members of a family of microcontrollers, and that information, which is common to all microcontrollers in the family, will land in a reference manual such as this one. SO8 assembly is fairly common across all of the SO8s, and so the assembly specific information has landed here in this book. Now, this book has a ton of really good information. It's actually written at a much more accessible level than the data sheet that we've been looking at so far. If we were to look at the central processor unit section, first off, you'll notice it's about 60 pages, so it's not something I'm going to expect you to read in full at this point in the class. Yet, it's really not the worst idea ever to go take a look at that information at this point. So we have pages that look very similar to what's in the other manual, except here you notice the detail on the accumulator in the programmer's model is much broader. It's much more obvious that this is meant to be a first introduction to the concepts. And in particular, it's worth mentioning that it has an entire section on addressing modes on page 89, which is much more in depth than what's in the book. It may prove to be a good supplement to what we've been talking about in the other series of videos. It also has a breakdown of instructions available on the family of microcontrollers by instruction type. They're slightly different to what I presented in class. I only used 3 categories with about 30 instructions each. It's going to use more categories than that, therefore having less instructions per category, but it's still sort of a neat way to look at what's going on. Another thing I want to point out is that there are assembly examples for at least lots of the commands. I think that you may find them useful in terms if there's a command in particular that you're not understanding, you could go back and learn from the example what's meant by the command. But now that I've covered some of the more interesting parts of the manual, I do want to talk in specific about simply one part of that. That's section 6.7, the assembly language tutorial. This, while written on the idea that you've at least seen assembly before, does cover some fairly basic commands. Assembly usually is one line per executable instruction. That's just a standard thing. Typically speaking, there's one line per executable instruction. Some things aren't actually executable. Mostly, those get a name, which is pseudo operations or pseudo ops. There are, roughly speaking, 4 pseudo operations that are of particular importance, and if you're going to understand how variables and constants are declared, you got to know these 4. These 4 are org, EQU, DC, and DS. Now, of these 4 commands, one of them is fairly easy to explain, EQU. EQU stands for equals. It's similar to a C style pound define. In C, where we'd say pound define Fred is 3, we mean compiler whenever I say Fred, I mean 3. Here we'll use EQU to tell the assembler, whenever I use this particular thing, I want you to use this other thing. However, it's going to follow assembly style syntax, which is to say that we have a label and then an operation. Even though this is a pseudo op, it still goes in the same spot as an operation, and then an operand. Now, in this case, the label is the thing that we're now going to refer to, and the operand is the thing that we want it to be equal to. So, for example, if I wanted to add define Fred to be 3, I would do something that looks like this. Fred label equals 3. And then at that point on, the assembler would know every instance of Fred, I want to just replace that and consider that to be 3. So next, let's talk about the DS command, which stands for define storage. Now, properly speaking, this thing is usually used with a dot and then either a B or a W. And defined storage in particular is mostly used with the B. So I'm going to write here that it's ds.b, and you can think of it this way. The B stands for byte. This command is the way that one can define variables. It takes an operand, and the operand is not .b, that's part of the command. The operand is the number of bytes that you wish to store. For example, if I said ds.b 5, then that would mean 5 bytes. It's worthless to most people unless you also put in a label. One might put, for example, Z. And if you were to do that, then the label would be Z. The label says that spot that I'm at in memory. Let's call that spot Z. And then it sets aside 5 bytes of storage. ds.b says I'm going to set aside bytes. The 5 says I'm going to set aside 5 of them. And then here's this comment. This then would be how one would create an array. If you wanted to create I, we would do it like this. We would say I ds.b 1, right? And we're done. We don't need the semicolon unless we're going to write a comment. We don't need a comment for this particular variable. Now it's worth mentioning this doesn't do any sort of error checking, boundary checking, anything else. It simply says I'm going to do 5 bytes and do this thing. And then please increment for me your internal memory counter that is saying where to put stuff. Now, in order to use this meaningfully, in order, for example, to say, hey, I want Z to be at 120 and I to be at 100, like we've been using in our examples, we have to also learn about the org statement. So org stands for origin, and it means allow me to select where I am in memory. The operand is just the location. The operand is the location in memory that you want to start at. And so, for example, if I were to put here, if I put a space to make sure I'm not in a label, I put org hex 0120, then that's saying, hey, I'm going to talk about the address 0120. And then the very next thing I'm going to do is I'll create 5 bytes of space, and I'm going to call those 5 bytes Z. Actually, worth mentioning, I'm creating a label right there at 0120, and then I'm going to set aside 5 bytes of space. Now, as it stands right now, I is currently going to have an address, which is not hex 100. This currently has an address of 0125 because 5 bytes of storage were set aside for Z. That means 0, 1, 2, 3, and 4 were set aside. So the next available one is 125. Now, if we wanted to make I have the origin that we needed, we can certainly come in and say org 0100. That would make that I be at the address that we would expect. It's worth mentioning, we can do really silly things. For example, we could say 121, and then I is going to go right in at 121. The assembler's not going to warn me. Nothing's going to happen differently. This is something assembly allows you to do, and sometimes you might want to give a couple of different names to something. But in this case, Z1 is equal to I. It is exactly and identically I. And that's probably a bad thing. That's not something that one would want most of the time. Assembly doesn't help you understand that. So let's move it to this. There we are, 100 and 120. Now, but why isn't this video over? Well, we've got one more thing. It's not something I need for variables, but it's worth mentioning that for constants, this thing gets used quite a bit. So this is actually just define constant, and it's only used in program memory. So we'll need that org statement to move us up into Flash, and then you can define constants in that space. There's both a dc.b for bytes and a dc.w for words. The difference here is the operands, and there are multiple operands, are the values we want. So how would I use DC? First thing I'd have to do is I'd have to land out in program memory somewhere. So let's do an org statement. And let's go out in memory to like F000. I know that that's out in program memory. I might make us a constant. So let's say like dc.b 5. Now that's not a terribly interesting constant, but it's there. We might need it, might want it. It's probably going to need a name if we ever want to use it. So let's give it an uninteresting name of 5. Since I don't know what 5 is necessarily, I could call it that. At this point, if I use 5, then I am referring to the memory address hex F000, which has a value of 5. So I can use load A statements to get at this 5. is very, very different than if I were to equate 5 to 5. You can also do multiples in one line. So I could say like my array, and then I could say dc.b 5, 6, 7, 8, 78, 9. 78 is well under 255. It still fits in 1 byte, so I'll just take what my finger said and go with it. This thing would have a size of 5 bytes because it has to go 1, 2, 3, 4, 5. Unlike DS, where we have to define how many bytes we need, DC is going to be defined simply by how many bytes there are. Last thing we might do is something like my string, and in this we would do dc.b, and we can use single quotes. We can say something like hello. It's worth mentioning this will not zero terminate like C would. You want it to be zero terminated, you get to come down and just put a dc.b and just put a 0 there. There's your zero terminator.